Hello, in this short tutorial I will illustrate how to generate a Python script that will run basic molecular dynamics simulation with atomic simulation environment calculator using specific selected universal machine learning interatomic potential. Uh, to do that, we will use application interface which is called u-MLIP interactive, and you can get it if you navigate to this GitHub link, and here you can find a tutorial for the compilation, and also previously I made a video how to use this application for some basic tasks like geometry optimization or calculation of elastic properties with universal machine learning potentials. So you can find it on this YouTube, and it will lead you to this video. So you can also search for it with this caption. Okay, so I will suppose you already have this application installed and run, and let's get now to the new feature of preparation of molecular dynamics script. So I will select this setup option, and let's say I have this supercell of alpha titanium where I placed some number of nitrogen interstitials, and I want to perform like NPT run with atmospheric pressure and with some higher temperature like 900 Kelvin, for example. Okay, so to do it I will use the NPT ensemble, and currently you can select from these. Then I can change any number of steps I want, so for how many steps the simulation will run, what should be the time step of the molecular dynamics simulation, then the temperature, so 900 Kelvin. I can modify the NPT control, so the isotropic. I can choose now if I want like as isotropic coupling, so each lattice parameters will change with the same ratio basically. Or I can also now modify it to have it as anisotropic, and for each lattice direction the target pressure, so now I want 0 gigapascal, then the pressure time constant and the bulk modulus, like these two are used to calculate a parameter for the basically how much the pressure will be forced on this specific value. Like if you choose higher values here, it will like it can more slowly converge to this target pressure. If you choose smaller values, it will more rapidly be forced at this pressure. So I will select, for instance, 200, and this I can keep like this. And this is also another constant which controls the temperature. So again, higher values mean it's less force to be hold on this temperature. Lower value means it will be more force to be at this selected temperature. So I will set, for instance, 40 here. Then I need to choose how often the simulation will print some basic information into the console when it will run, and also each step that will be saved as a trajectory from the run. So I will reduce it for 20 now, and that's it. So now I can, and one more thing is the universal potential that I want to use. So currently you can choose from these options. Mainly you can select a certain model from Maze or from ORB or NeQuix, and also Hagenet or 7net, and MatterSim as well. Okay, so then I can change if I want to calculate either on a GPU or on CPU, and how many CPU threads I want to use. So I will calculate on GPU, which is much faster, and just I will have it like this. So then I can click on this generate button, and it will give me the full Python script that I need to run on my crystal structure file. So I will copy this and then go to this console, and in this console I have this postcard file, like the structure that I want to use for the simulation, and then I will create this Python script and insert here the content that I just copied, save it, Ctrl S, exit, Ctrl X, and now I can run this Python script. And just don't forget that you need to activate the Python virtual environment into which you compile all the prerequisites from this application, so which is basically the prerequisites are mentioned in this requirements file. Okay, so now I will run it, and I selected for example this MACE universal machine learning potential with MATBES and R2 scan, and you can see it's running and it's printing some basic information. So the current step, out of how many steps, the current temperature, the current potential energy, kinetic energy, the total pressure, and how much GPU memory is used, since I selected the GPU calculation type, and the estimated like simulation time per step, and like the estimated remaining time calculated from this average times how much each step took, multiplied with the remaining number of steps. So now I could either let it run, or if I just stop it, it will let me show you that it will calculate also some basic graphs which may be useful. So I will stop it with Ctrl C, and it generated me in this folder where I run it some information. So I have here the trajectory. I can show you. Okay, I need to just restart the Ovito. And I need to, the coordinates are not wrapped, but I can easily do it with this option. And yeah, you can see how the structure is changing after these just basically 700 steps. And then just for the information, it created automatically some basic graphs. So here you can see like how the kinetic energy is changing with the simulation type, then how the values of the lattice angles are changing with time, the lattice parameter ABC, how they are changing with time, and in percentage you can see how they are changing with time. Like here are the absolute values, here is the percentage of change, then like the graph for potential energy with time, pressure versus time, temperature versus time. So you can see how it basically converging, how is it converging around a set temperature, or fluctuating around a set temperature, and then like total energy versus time. And last thing is that it created also like the last step from the trajectory file in WASP format. So this I can use For instance, if I want to continue with the simulation, so I can use this file as the new initial file instead of this one. And the script automatically reads the structure which are in the same folder as the script. So if I put here 2 files, it should run the simulation for one file and then move to the second file, and it reads the file if they are either in WASP or like WASP format or a ZIP format. So you can see this. In my case, it automatically found this structure file. Okay, so if I want to run like NVE or NVE or NVT ensemble, I can simply do it if I select these options from this UI, and then again regenerate this Python script, just copy it and insert it as the content for this file. Okay, so I hope this tool will be useful for you, and thank you for your attention. And just maybe one thing, it's very easy to change the universal machine learning potential. For instance, if I will use this orb, I just select it here and then generate it again and copy it, and now if I run it, it should start with this orb universal potential. Yeah, you can see it initialize it on the GPU, and it will start soon running the simulation. This just needs a little bit more time for the initialization, like the orb needs a little bit more time. Yeah, now you can see it starting, but otherwise it's even faster than the previous potential. But this can also be because I choose NVT, not NPT ensemble. Okay, so that is all, and thank you again.